All right, so scientists, some, are sounding the alarm on a so-called solar superstorm that could, and this is important, underline the word could, eventually wipe out the internet for weeks or even months.
Electronic satellites suddenly go out of control. There are voltage surges across the globe. In some places, there's a complete blackout. Scientists have little data on this incredible solar behavior, so we're still unable to accurately predict how or when exactly the next geomagnetic storm will happen. This isn't science fiction, nor is it a drill. This is the real deal, a rare and potent phenomenon that promises to illuminate our skies and impact our planet in ways both beautiful and profound. As this massive blast of plasma and magnetic fields makes its way to us, we stand on the brink of witnessing a natural marvel that underscores the dynamic and powerful connection we share with our sun. Before we dive into the current celestial drama unfolding above us, let's take a moment to demystify what geomagnetic storms actually are. Understanding geomagnetic storms. Imagine the Earth floating in space, surrounded by a protective shield known as the magnetosphere. This invisible shield is our planet's first line of defense against the sun's relentless outpouring of radiation and energetic particles. But what happens when this shield is shaken by the solar system's own tempests? Enter the coronal mass ejection, or CME, a massive explosion of plasma and magnetic fields from the sun's corona, its outermost atmosphere. These solar eruptions can hurl billions of tons of coronal material into space at speeds that can exceed a staggering 2,500 kilometers per second. When these charged particles collide with Earth's magnetosphere, they can trigger what we call a geomagnetic storm. But how do we measure the fury of these storms? That's where the planetary K-index comes into play, a scale that gauges the magnitude of geomagnetic disturbances, ranging from 0, a calm magnetic field, to 9, a storm of extreme intensity. This index helps scientists assess the potential impact of geomagnetic storms on Earth. The severity of these storms is classified into 5 levels: G1, minor; G2, moderate; G3, strong; G4, severe; G5, extreme. Each level brings its own set of challenges and phenomena, from the beautiful auroras dancing in the night sky to more disruptive effects on communication systems, power grids, and even wildlife navigation. As we turn our gaze back to the skies, the NOAA Space Weather Prediction Center has issued a watch for a geomagnetic storm, sparked by a CME that erupted on September 15, 2023. This storm is predicted to reach a G2 or moderate level. What does this mean for us? It heralds the possibility of witnessing the aurora lights, a mesmerizing display of colors in the sky in certain parts of the world. Current geomagnetic storm watch. As we navigate through the cosmic currents of space weather, our focus shifts to the present, a geomagnetic storm watch issued by the NOAA's Space Weather Prediction Center. This alert has been sparked by a coronal mass ejection, CME, that occurred on the sun's surface on September 15, 2023. This storm, a swirling mass of plasma and magnetic fields, is hurtling towards us at incredible speeds, and it's expected to graze our planet's magnetic field, triggering a geomagnetic storm of moderate intensity, classified as G2 level. But what exactly does a G2 level geomagnetic storm mean for us here on Earth? For starters, it's a ticket to one of nature's most spellbinding shows, the aurora lights. These celestial curtains of color, also known as the northern lights, are caused by the interaction of the solar particles with the Earth's magnetic field and atmosphere. Under the influence of a G2 storm, the auroras can push further into lower latitudes than usual, making them visible across more parts of the world, including some regions of the United States. Imagine the night sky lit up with hues of green, purple, and pink, a silent symphony of light dancing across the darkness. Places like Alaska, Montana, North Dakota, Minnesota, Wisconsin, Michigan, Maine, and New Hampshire stand a chance to witness this ethereal display. However, catching a glimpse of the auroras isn't as simple as stepping outside and looking up. Visibility depends on several factors, including local weather conditions, light pollution, and the time of the night. Impacts of geomagnetic storms. As we brace for the arrival of the geomagnetic storm triggered by the recent coronal mass ejection, it's crucial to understand the myriad ways such cosmic events can impact our planet. Geomagnetic storms, while awe-inspiring in their display of aurora lights, carry with them a spectrum of effects that ripple through our technological infrastructure and the natural world. Let's explore the dual nature of these impacts, both the challenges and the unexpected benefits they bring. Communication systems. One of the most immediate effects of a geomagnetic storm is on our communication networks. The storm's charged particles can interfere with radio signals, leading to blackouts, distortion, and interference. This doesn't just mean your favorite radio station might go static. It can disrupt essential communications between emergency services and impact the functionality of navigation systems in aviation and maritime sectors. Recall the incident in 1989 when a geomagnetic storm caused a radio blackout affecting the Space Shuttle Discovery. For a tense 15 minutes, astronauts lost contact with mission control, a stark reminder of our vulnerability to solar weather. Navigation and GPS. In today's world, we heavily rely on GPS for everything from navigating our daily commutes to timing financial transactions. A geomagnetic storm can introduce errors into GPS signals, leading to inaccuracies. Imagine a world where your navigation app leads you astray, or worse, critical transport and logistics services are disrupted. In 2011, a geomagnetic storm caused GPS errors significant enough to affect aviation and maritime navigation, though thankfully without causing any accidents. Power grids. Perhaps one of the most significant impacts of a geomagnetic storm is on our electrical power grids. Induced currents can flow through the ground and into power lines, transformers, and power stations, potentially causing voltage instability, equipment damage, and large-scale power outages. The 1989 blackout in Quebec, Canada, serves as a dramatic example, where millions were left without power for 9 hours due to a geomagnetic storm. Satellites. Satellites, the backbone of our global communication and navigation systems, are not immune to the effects of geomagnetic storms. Increased drag, radiation exposure, and charging can degrade satellite components, disrupt operations, and even knock satellites out of orbit. The loss of a satellite can mean a loss of critical data and services, ranging from weather forecasting to global communications. Wildlife. The natural world also feels the effects of geomagnetic storms. Many species of animals, including birds, fish, and sea turtles, rely on Earth's magnetic field for navigation and migration. A geomagnetic storm can disrupt these magnetic cues, leading to disorientation and affecting the natural behaviors of these animals. Instances of birds flying off course or whales beaching themselves have been attributed to the disorienting effects of geomagnetic storms. Yet it's not all doom and gloom. The same geomagnetic activity that poses challenges also gets us with the stunning aurora borealis and aurora australis, visible further from the poles during strong geomagnetic activity. These natural light shows remind us of the beauty and interconnectedness of our planet with the cosmic forces of the solar system. From the impacts of the storms, let's shift our focus to viewing the aurora lights. Viewing the aurora lights. In the wake of the geomagnetic storm watch, many of us are eagerly anticipating one of the most mesmerizing natural spectacles on Earth, the aurora lights. These vibrant curtains of light, known as the northern and southern lights, are not just a feast for the eyes. They're a vivid demonstration of the Earth's connection to the sun. As the solar storm approaches, bringing with it the potential for dazzling displays across the night sky, here's your guide to witnessing this incredible phenomenon. Finding the perfect spot. The first step to witnessing the aurora lights is finding an ideal location. You'll want a place far from the light pollution of cities, where skies are dark and clear. The darker the environment, the more vivid the auroras will appear. Seek out remote areas, parks, or countryside locations known for their unobstructed views of the night sky. Timing is everything. Auroras can be elusive, and their visibility heavily depends on the timing of the geomagnetic storm's interaction with the Earth's magnetic field. The best time to watch is usually around midnight, local time. However, aurora activity can vary, so it pays to be vigilant and flexible with your viewing plans. Use technology to your advantage. Leverage online tools and apps designed to forecast aurora activity. Websites like the Aurora Forecast, Aurora Service, and apps providing real-time alerts and predictions can be invaluable in planning your aurora viewing adventure. These tools offer insights into the best times and places to view the auroras, taking much of the guesswork out of your hunt for the northern lights. Dress for success. Remember, the best aurora viewing often happens in cold, nighttime conditions. Dress warmly in layers and bring along blankets or a hot beverage to keep comfortable as you gaze skyward. Capture the moment. If you're keen on photographing the aurora, a good camera is a must, preferably a DSLR or a high-quality smartphone camera. Use a tripod to stabilize your shots and consider a wide-angle lens to capture the vastness of the night sky. Experiment with longer exposures to allow your camera to catch the aurora's colors in all their glory. Patience pays off. Aurora watching can be a waiting game. The lights may appear faintly at first or take time to emerge. Patience and persistence are key. Keep your eyes on the sky and you might just be rewarded with a dazzling display. As the geomagnetic storm draws near, the excitement builds for the chance to witness the aurora lights in action. Whether you're a seasoned aurora chaser or a first-timer eager to see the night sky come alive, this event is a reminder of the beauty and wonder our planet offers. So grab your gear, plan your outing, and get ready to be enchanted by one of nature's most spectacular shows. Stay tuned for more updates and tips on making the most of this extraordinary event. Happy aurora hunting! We hope you found these facts intriguing. If you've heard them before or have any thoughts to share, please let us know in the comments below. Remember to subscribe to A World to Discover for more interesting natural phenomenons.